physics and mathematics kind of sciences, theory of probability, and the topic of the dissertation is simulation of records and extreme values. I am declaring this session open. Dissertation by Artem Igorovich Pakhteev, and I would like to unfortunately announce a technological break so that we could remove some obstacles, technological obstacles. Thank you very much. The break, I hope that's 5-10 minutes will be enough to remove all the technological glitches. Thank you. Dear colleagues, the technological break is over, and I would like to continue our session. Do you have any objections? Therefore, I can continue our session. First of all, I would like to draw your attention to the membership of the Dissertation Council by the Act of St. Petersburg University dated 15th of June 2020. I, Nikolai Kimovich Krivulin, Doctor of Physics and Mathematical Sciences, Professor of the Department of Statistics, Melnik, St. Petersburg University. I was appointed Chairman of the Dissertation Council. Also, members of the Dissertation Council include Vyacheslav Borisovich Melas, Doctor of Physics and Mathematical Sciences, Professor of the Department of Statistical Modeling, St. Petersburg University, Andrei Nikolaevich Frolov, Doctor of Physical Mathematical Sciences, Professor of the Department of Theory of Probability and Mathematical Statistics, St. Petersburg University, and also Nadezhda Viktorovna Gribkova, Doctor of Mathematical Sciences, Physical Mathematics Science, Professor of the Department of Higher Mathematics, St. Petersburg State University, named after Emperor Alexander I. Also, online with us is Leonid Viktorovich, Doctor of Mathematical Sciences, Professor of the Department of Mathematics, St. Petersburg State Chemical Pharmaceutical University. Unfortunately, he cannot go online with the video. We have only an audio connection with him. Leonid Viktorovich, please, my suggestion is to participate in this Dissertation Council as a participant who can voice his opinion and participate in the discussion. If the visual connection is not restored, then we can still invite him to participate for the voting, etc. Because through audio connection he can participate fully in the work of council. Another member of the station, Tomasz Ryklik, Doctor of Habilitation of Physical Mathematical Sciences, Professor of the Department of the Institute of Mathematics of Polish Academy of Sciences. Can you hear us, Professor Ryklik?
Yes, I can understand. I can hear and understand.
Thank you very much. Also, Frolov Andrei Nikolaevich, can you hear and see us? Yes, everything is fine. I would like to add that the original council included 7 members. Unfortunately, Professor Yuri Nikitin is deceased, and unfortunately we have to work without him. Nevzor Valery Borisovich is also participating in the capacity of an observer and as an advisor to one of the works that we're going to discuss today. And also the applicant is present, of course, Pakhteev Artyom Igorovich, and we'll be happy to hear listen to what he has to say. Also online with us is the academic advisor of the applicant, Stepanov Alexei Vasilievich, Professor of the Baltic Federal University Department of Applied Mathematics. Can you hear and see us? Yes. To improve the quality of the connection, I would like to ask you to switch off your microphone, and only when you're given the floor, then you switch on your microphone. Another comment, well, an audio and video broadcast is on the website, and simultaneous interpretation between Russian and English for the participants of our session from Poland. Online with us on the website of St. Petersburg University. There's a direct link to our broadcast, and also can be used by anyone who could wants to send a question that has to do with the procedure and the content. So, as far as the questions that have to do with the dissertation, they have to be relevant to the dissertation. Anyone who wants to send a question should sign and cite an affiliation. Questions that are irrelevant to the academic discussion will not be read. In accordance with the regulations of awarding academic degrees of Candidate of Science and Doctor of Sciences in St. Petersburg University, hereinafter the regulations, the session of the Dissertation Council is viewed as legitimate if not less than 2/3 of the established membership of the Dissertation Council is present, but not fewer than 4 people. Our Dissertation Council consists of 7 people, 6 are present, and 2 members of the Dissertation Council working in online mode. And therefore, 4 people anyway are present live here, and at least that, so the quorum is there. And there's another member of as I mentioned, then there's an audio connection with 1 member, but hopefully I will restore the video connection as well. The following agenda is presented before you, and the first item is a short presentation of the chairman about the paperwork of the dissertation applicant related to the dissertation. 5 minutes for discussion if we need it. A short presentation of the applicant that cover the key issues of the dissertation, up to 15 minutes. Questions to the defendant based on the presentation, not more than 2 minutes per question. Answers of the applicant, not more than 5 minutes for all questions. Then presentations of all members of the Dissertation Council with interns with their reviews, about 10 minutes per speaker, and you can ask questions of the applicant. Then the chairman will then read his review, then not more 10 minutes, and then the defendant will be given 20 minutes to respond, and then the floor is open for a free discussion with anyone present here. not more than 2 minutes per question, or, as I mentioned, questions sent to us by email also will be read. If we have reviews, outside reviews, then I will read them as well. Then we have academic advisors presentation not more than 3 minutes. Then the dissertation council members will deliberate on the resolution and not more than 5 minutes, and then an open voting procedure, and then the counting of votes by the chairman, and entering the results into the minutes, and then a decision will be taken to award or not to award the sought academic degree, and then concluding statement of the applicant not more than 2 minutes. Do you have any questions on the procedure? Do you agree to it? No objection, so that's fine then. Therefore, I'm starting going through the agenda. The first one is about the paperwork that I've received. Let me read this. The dissertation of Artem Igorovich Pakhteev seeking a degree of academic physical and mathematical sciences in the field of theory of probability and mathematical statistics was accepted for defense by the Academic Secretary of St. Petersburg University on the 11th of June 2020. Artem Igorovich wrote his dissertation in the Baltic Federal University, named after Immanuel Kant, and he was advised by Doctor of Physical Mathematical Sciences Professor of the Federal Baltic University, Alexei Vasilyevich Stepanov. The number of publications is 7 in the refereed journals of the Minister of Russian Federation, 1 publications, and 4 publications in the journals indexed in the Web of Science in Scopus. The full paperwork has been presented to the Academic Secretary of St. Petersburg, and they comply with clause 12 from the regulations. All the documents comply with the requirements and are entered into the file of the dissertation applicant, and they're available from the Office of Dissertation Council Support. Before I give the floor to the applicant, I would like to ask the members of the dissertation council, is there any need to list all the documents? No. Therefore, I would like to give the floor to the Artem Igorovich. Please, over to you. Dear members of the station, my name is Artem. I come from Kaliningrad, and in your university, wonderful university, I would like to give a short overview of my dissertation work. The dissertation, Statistical Mathematics of Records and Extreme Values, the theory of extreme ordinal statistics and records is important and relevant in connection with various applications arising in actuarial and financial mathematics, meteorology, hydrology, reliability theory, and medicine, etc. In the course of the development of the theory of extreme and ordinal statistics and records, separate directions imagine it an interesting and popular modern direction in the development of the theory of the extreme ordinal statistic and records is the statistical modeling of these random variables. Modeling records and streams is important for a variety of applications. These can be tasks related to industrial stress and strength testing, problems of game theory and financial mathematics, etc. Suppose that the developers of a certain, well, it's important then in biostatistics. Suppose that the developers of a certain medicine are interested in the effect of the drug on the blood pressure parameters of patients. Clinical studies show that the pressure readings after using this drug have a normal distribution. Generation of maximum and minima of large normal supplies allows stimulating the behavior of maximum minima of blood pressure in patients with massive use of the drug. The goal of the dissertation work includes the development of algorithms for generating large sequences of record moments, magnitudes, and maximum based on the inverse transformation method and the sampling method with deviation declining, and as well as conducting statistical modeling experiments with records and maxima and deriving the limit theorems for spacing of discrete record values. The results: new efficient algorithms for generating large sequences of record values obtained from samples with normal distribution and gamma distribution have been proposed and implemented new efficient algorithm for generating large sequences of record times and normal maxima. Proposed and implemented new efficient algorithm for generating large sequences of record quantities and with discrete distribution. Generation algorithms are based on the Markov sequence of record moments and values and derived limit theorems for discrete record space. The academic novelty of the results obtained in the dissertation work is as follows. First, for the first time, algorithm for generating sequences of record values obtained from samples with a gamma distribution with the shape parameter and respectively are proposed in this work. These algorithms allow generating large sequences of gamma records up to 2 billion record values. New efficient algorithm for generating record values obtained from a normal population are proposed. It is shown in the work that these algorithms are significantly faster and more efficient than all previously known generation algorithms. Algorithms for generating record moments in the general continuous case are proposed for the first time in the thesis. The paper proposes new efficient algorithms for generating the maximum of normal samples. Limit theorems for spacing differences of discrete normal values are derived from in this work. Algorithms for generating discrete record values are proposed for the first time for the thesis. The work uses the following basic notations. Fx is the distribution function, Fx is the density of the absolutely continuous case. In the discrete case, Pn is the probability function, Qn is the tail of the distribution F. Let x1 to xn will be a set of random variables. These quantities located in non-decreasing order are called the ordinance called ordinance statistic. Let Mn Sx be the maximum of the sample. Let's move on to general information about ordinance statistic rates and methods. Regenerate record numbers. Then you have it's important that the sequence of record moments forms a Markov chain where record moments do not have mathematical expectations. The joint on the slide you see the joint distribution density of the quantities x1 to xn has the form shown on this slide. From the last equation, then we can derive the distribution function for the quantity xn from the joint density of record quantities. One can also obtain the condition density of the quantity xn, provided xn. Note also that sequence Sx x1 to xn forms a Markov chain. In discrete case, the record moments Ln were not studied in the work. Record values xn from a Markov chain. Form a Markov chain. Consider methods for generating continuous random variables. First generation method is the inverse transformation method. Reverse transformation method. The method is based on the Smirnov transformation. If the inverse distribution function f minus n x can be found analytically, then we generate a random number u equals u and put x equals f minus 1 u. And in the case when it's difficult to find the inverse function, it is reasonable to use the deviation sampling methods. Deviation sampling, suppose we can generate a random variable y with density g by the inverse transformation method. Suppose we also that it's possible to generate a random variable x with a distribution density f by the inverse transformation method. Let the distribution x and y have the same support. We define a constant c greater than 1 by the equation c by the p equals support x sub x algorithms. Step 1 generate the value y, etc. And now in this slide you can see, let's look at the generation of records. The simplest is the direct method. The essence of the direct method is as follows. We generate a random variable x, 1 equals x 1 for n greater or equals 1 to use a recursive approach which assumes that the value xn has already been generated. Then we generate the value xi until the event xi greater than xn occurs for some I. We put xn plus 1 equals xi. The direct generation method allows generating record sequences in both discrete and continuous cases. Consider the gamma records. Let fx alpha be a gamma distribution with a large parameter alpha greater than 0. The scale parameter is assumed to be equal to 1, and fx alpha will denote the distribution density function, i.e. the conditional density of the value Sx at a fixed value of xn, xn plus 1 at a fixed value of xn, as the form shown on the slide. We'll use it to output the generation algorithms. It should be noted that for alpha equals 1, the gamma distribution generates into an exponential distribution. The generation algorithm for this case is well known. See, for example, Bayramov, Stepanov, Krishnan, Schuetzer. Generating random numbers ui, we 1 I is greater than 1 and or equals and greater than equals n. Then on this slide you can see that algorithm for generating gamma records for alpha belongs not 0.1, algorithm 3.1.2, the sequence n, xn. Well, there's can I continue? The second step, the first step is x1 equals x1 with distribution function fxn x slash alpha by deviation sampling. Step 2, we generate a random number u1 equals small u1, generate y equals small y with a density g. Step 3, we generate a random number u2 equals small u2, and if small u2 is less than y slash xn, alpha minus 1, then we'll put xn plus 1 equals y. Otherwise, we go back to step 2. Now it can be shown that c equals c xn, and then 2, 1 as xn to infinity. And then algorithm for generating gamma records for alpha greater than 1. You can see here that the correctness of the results obtained was verified in the following way. For the case of alpha equals 0.5, the first 10 gamma records were generated a million times. The mean values and the matrix of estimates were found using numerical integration. The vector of mathematical expectations and the values of the covariance dispersion matrix were found for the first 10 record values taken from sample with a gamma distribution with the parameter alpha equals 0.5. The results were then compared. It turned out that the vector of mathematical expectations, the covariance variance matrix, are close to their estimates obtained as a result of the generation. A long 2 billion value sequence of gamma records generated using algorithm 3.1.2 is shown on the slide. Using the direct method of generating records, it was possible to generate a sequence consisting of only 25 records while spending much more time. A home computer was used for numerical measurement. The member of the Dissertation Council, Professor Thomas Richlik, noticed the following: when generated at alpha equals 0.5, gamma records for large n behave like xn approximately n, which is typical for exponential records, i.e. when alpha is equals 1. I generated gamma record sequences for different values of the a parameter. It turned out that xn is approximately equal to n. It's true for the old generation of gamma records for large n. If I have found that I can show that the gamma records for any alpha greater than 0, it is true. And then let us now consider generation of records that correspond to a normal distribution. Let phi be the standard normal distribution function in its density. Since normal records also form Markov chains, the algorithm for generating a sequence of normal records is based on the conditional density formula. The first negative normal records are generated directly, then a biased sampling method and the recursive approach are used to generate normal records. Based on this, the following algorithm is built, and also algorithm 3, and then now you can see algorithm 3.2.1. Step 1, generate x, 1 equals to x1 by direct method, generating records until the event xi greater than 0 occurs. Step 2, generate random numbers u1 equals small u1, u2 small equals small u2, and enter the notation that n step 3, if the condition is in the third step is met, then we put xn plus 1 equals x. Otherwise, we go back to step 2. Two alternative algorithms were proposed in the work, the most effective in the presented on the slide. The correctness was checked using the chi-square test, chi-square test. No contradictions were found. Additional another statistical modeling experiment was performed with the help of numerical integration. The mathematical expectations were found for the records extracted for the normal population. Then, using the algorithm, the values of the first 110 records were generated 1 million times, and their average values were found. Visual comparison: the slide shows that the difference between the mathematical expectation and their estimates are small. This indicates that the algorithm is very efficient and generates long segments of normal records. In addition, the algorithms were compared with the previous known algorithms for generating normal lines. Balakrishnan, So and Zhu 2016 discussed 5 algorithms for generating normal scores. We tested these algorithms and statistical modeling experiments. We performed statistical modeling experiments. The performed experiments have shown that the algorithms of the above work can efficiently generate only short segments of normal records. Briefly about the generation of record times. The general continuous case and normal maxima. As noted earlier, record numbers from a Markov chain form a Markov chain. This equality is the basis of the generation for the generation algorithm. Algorithm 331. The sequence L can be generated as follows. We put L1 equals 1 to generate L and greater or equals 2. We use the recursive method, and we see that on the slide some results of the use of the experiment, statistical experiment. Now we'd like to turn to, well, not more than 5 minutes. Also on the slide you see the algorithm, for normal maxima, the sequence m n greater than or equal to 1 can be generated as follows. Step 1, by the record method of generate record moments and values, we generate record values x1 equals x small x1, etc. For step 2, generate random numbers u1 equals u1, u2 equals u2. Step 3, let y equals small y small x n minus 1n and so on. And then step 4, generate a number v and equals small v and set, and the following generation results were obtained. And the fourth chapter of the work is devoted to limit theorems for discrete record spacing. In this chapter we assume that x1, x2 are independent, identically distributed random variables taking values 0.1 with a distribution function f such that fn is smaller than 1 for n 1, 2, etc. Here we will consider the asymptotic properties of spacings of discrete record quantities. If beta equals 0, then we call the tail of the distribution thin. If 0 of beta is greater than 1, is less than 1 but greater than 0, then we mean if beta equals 1, then thick. The if the tail is thick, and then the new record value jumps for far ahead, and the difference x plus 1 and minus xn tends to infinity. You can see the last chapter is devoted to the generation of discrete records. We assume that x1, x2 are independent, identically distributed random variables that take values not 0.1 with the distribution function f such that fn smaller than 1, etc. The first then algorithm step 1. Well, the conditional distribution function of the record value Sn n plus 1 under condition has the form on the slide. Algorithm 5.11 is step 1, generate x1 by the inverse transformation methods. Step 2, generate a random number u equals u. We put x n plus 1 equaling m. If in the case when qm is difficult to find analytically, a generation algorithm is based on a deviation sampling. A method can be used to generate discrete methods. Suppose that the value x equals I greater or equals n minus 1 has already been generated. Let y be a discrete random variable which can be generated by the inverse transformation method with the probability function g k m plus 1 defined on the set I plus 1, I plus 2, etc. Algorithm 5.1.2, a sequence of discrete records n generate x n greater than 1 generated as follows. Thank you very much for your attention. Thank you very much for your interesting presentation. Do you have any questions to the defendant on the presentation? Well, I'll start then. If there are no questions, then I will ask my question. In your presentation, you always mentioned a higher effectiveness of your methods compared to the existing methods. Do you have any justification of evidence? Did you measure the complexity of computation of these algorithms, or do you base your conclusion on some other grounds? Well, we didn't calculate the complexity. Our algorithm are treated whether they form a Markov chain, and well, there are very many empty generations in other cases, and longer sequences more difficult to obtain. So time-wise, the modeling can be faster. Thank you very much. Any other questions? Have you ever tried to tackle distributed calculations with distributed programming? You have to have skills which I don't have, but we used for generation record of the previous value, and when we have parallel computation, then on different cores of the computer we have parallel, well, different the computations. Well, of course, distributed computation will decrease the time of calculation for computation. Any questions? Yes, can I ask a question? Valery Borisovich, please. How does it take? How much time does it take to generate a million? Just seconds. Not years. Just about 1,000. A million takes about 1,000 seconds. Well, the direct method, 25 records were generated for 65,000 seconds, and some we couldn't. We stopped waiting for. Yeah. Well, I like everything, and then everybody likes everything. Okay, good. Just one question on technical, the technical side. Well, you said that you don't have deep programming skills, but have you used so many programming tools? For example, have you used any programming language? All calculations were used were done by with the help of MATLAB software package. Well, I can do programming, but parallel programming is a bit too difficult for me. If we have no more questions, then we would like to go over to the reviews based on the presentation and the registration. Yes. Well, no external reviews, and therefore we can proceed to the reviews. Vyacheslav Borisovich, will you start, please? Thank you very much. I'm not going to read my whole. I will just read the concluding part, even enumerating the everything. What is done, that is great work, and a lot of work has been done. Just let's point out some questions and distinction. Page 17, it says that the condition Fn less than 1 guarantees the existence of the sequence of discrete records. So with the probability of 1. Could you explain that? In lemma 221, you should have formulated the conditions in which this statement is true. And also in the second formula on page 33, there's a typo. You should have reversed, upside down the fraction in the second logarithm on page 38. In the first line, you cite the duration of the work of the program up to 6 digits after decimal, etc. After the pointer, and it's not clear why do you need such precision. And this statement is true to the whole work. Well, and then I never saw in the work the main idea on which all algorithms of generating records are based. Well, nevertheless, these criticisms are of a formal nature, and they diminish the value of this distinction. The algorithms of generating work and show good efficiency. Therefore, I would like to conclude that the distinction of Artem Igorovich Pakhteev on the topic statistical modeling of records and extreme values meets the main criteria stipulated in the regulation dated 01/09/2016 on the awarding of academic degrees in St. Petersburg University. And the candidate, Artem Igorevich Pakhteev, deserves being awarded an academic degree of Candidate of Physical Mathematical Sciences and the degree field Theory of Probability and Mathematical Statistic. The item of 11 of the regulation has not been violated by the member of the Station Council, Dr. Physical Mathematics and Professor Melas. I would like maybe thank you very much. I would like to thank Vyacheslav Borisovich for the review. You write on page 17, it says that the condition of n smaller than 1 n guarantees the existence of a sequence. Yes, indeed, this point should be explained in more detail. If the above condition is not met, then there's a last point of growth of the distribution function f with probability 1. A certain record value will hit this point, and the sequence of records will be terminated. In lemma 2 to 1, one should clarify the condition under which this statement is true. Yes, I completely agree with the opponent. There's a typo in the second formula on page 33. The fraction should be reversed in second logarithm. Yes, there's a typo in this place. On page 38, the first line gives the running time of the program to 6 digits after the dot. I totally agree with this remark. Nowhere is in the dissertation I saw statement of the main idea in which, yes, this remark is especially relevant. Indeed, all algorithms for generating record moments and values are based on the marks of records. However, this was not clearly stated anywhere in this. So thank you very much. Do you? Are you satisfied? Yes, I am. Nadezhda Viktorovna, please. Group call. On the whole, I view this work as positive. Well, practically, I would need moments of emerging of this events and so imitation. Well, imitation moments, simulation moments are discussed in the work, and the algorithms are interesting. The results, I will not read out the whole review, but I will just jump over to my critical statements. Well, you probably answered my objections, but also the same thing. I thought maybe I was not attentive enough in reading, but the main idea was not there. As far as the formulations, the first one, motivation part is lacking. You have a chapter called the state of the art in the field. You cite some names, some sources, but what was done and why you decided to write this work, I couldn't find it. Well, this goal setting should be put forward up front. And the dissertations are written for specialists, by specialists. So the enlightenment part can be dropped. Well, this Smirnov transformation, everything is it's a well-known fact. And the calibration method that you use is less known. You should have focused on it more. well, the fast and the effective. You said that you devise something fast and effective. Effective sounds like the best, but maybe you should have used different notion. Well, this would be it probably. Well, you dropped some proof somewhere, so I didn't find. Yeah, I will put it up on the slide. Smaller than 0, larger, greater than 0. Well, this question will be answered. Well, thank you very much for your very accurate criticism. As far as the state of the research, the session is limited. I agree with the opponent. A brief analysis of the work process and the structure would be appropriate. As far as the commonly known basic concepts that are present, I would be nicer to introduce special designation concept that our algorithm submitted. As far as the your comment about 5.1 with alpha equals 0. For alpha equals 0, we have un plus 1 is n greater than n, and n is greater than right. Well, the result follows where a is alpha equals 0. Well, yeah, I just added it. Thank you very much. As far as the conclusion, well, my conclusion about the positive attitude to this work and the appreciation of this work is absolutely identical to the previous speaker's one, so I will not read it. Andrei Leonidovich Frolov, can you hear us? And please read your review or just speak about the work thing. Can you hear me? Well, thank you very much. Dear members of the Station Council, dear listeners, I will not repeat what was to describe the work, but I will just say that the results are of interest, but only of a theoretical value so far. But further research have potential to become applicable, and especially with the use of the algorithm. I will explain a bit later why we need a deeper analysis, and then I will go on to my presentation. 7 works have been published, and 5 of them are co-authored. Well, I would say if the contribution of the of the author is more than half, then that's enough. Then, but if the academic advisor of the dissertation will comment on this, as far as the some of the methods that you use by Mikhailov, etc., have been described. The author has some different names, but and so my criticism is this: the algorithm here can be unoptimal. For short sampling, it won't matter, but for the to check the quality of generation, the author then the author uses only 10 records. So the other methods can work also effectively, and as far as the time, you talk about billions of sequences. Maybe I didn't see it in the dissertation, but what is the cycle? What's the cycle of the sequences of evenly distributed samples? So, therefore, when you talk about 10 records and sequences are billions, so there's a discrepancy. The results are important, but our theoretical value. But it can contribute to statistical research. But to be able to build a long sequence, that's great. But we need a longer sequence for practical applications. So this is my criticism. That's why I said that the next, as far as the to check the quality of generated gamma and normal records, the author uses the chi-square test. In the case of continuous distributions, the Kolmogorov test of omega square is perhaps more appropriate. Indeed, well, they're based on the empirical. Well, this is again, it's a debatable issue, but also there's no statistical analysis of the generation of record times at normal highs. Well, not maybe big criticism. And the fifth one is that this is just to meet the requirement that the reviewer read the dissertation very attentively and found some drawbacks. I think the dissertation is good, is well written. When I open the table of contents, I can see what is in it, about what the author writes, and so the dissertation is a value. Formally, I endorse the resolution to award the third degree. Thank you very much, Andrei Nikolaevich. Thank you very much, Andrei Nikolaevich, for your very fair comments. I would like to answer some of your questions, and the first one about the 7 publications, 5 of which were written jointly with the supervisor. I hope that my contribution was proportional to the number of participants. I think it's better to ask my supervisor about this. As far as the algorithm for Molnagers that are well known by Yermakov and Mikhailov, yes, yes, Yermakov and Mikhailov was the first one, first book to introduce this in the literature. I the name deviation sampling method prevails. I used this name. As far as the check the quality of generated gamma and normal records, indeed the Kolmogorov-Smirnov criteria of the omega square may be more appropriate. However, I'm used to using the chi-square test. As far as the well, I'm used to using the chi-square test. Yes. As far as the statistical analysis of the generation of work at times and normal highs, maxima, fair remark. Such an analysis is easy to do for small values of n, but as you wrote in another note, such an analysis is desirable for large samples. I hope that in the future I will be able to carry out a comprehensive statistical analysis of maxima and maxima for large and publish the results of such an analysis. Well, as far as your remarks, that the criticism I finished. Should I say anything? Thank you very much, Artem. Andrei, are you satisfied with the answers? Yes, totally. Well, he proved my considerations and everything. That's the case, yeah. Thank you very much. We have one member of the Dissertation Council, Razovsky Leonid Viktorovich, who is online with us. Just as I'm online as well with video, and well, you're given the floor to present your in my review, there's nothing really negative. A number of critical remarks that have to do with cosmetics. But, for example, on page 26, the derivative is not drawn correctly. Well, fortunately, this mistake didn't affect anything further, and everything is correct. Well, all these there are typos and such, but these critical remarks don't diminish the value of the dissertation. So, well, maybe some formulations should be corrected, smoothened out. But I would like to side with my colleagues, the previous speakers. Everything is well written, and the dissertation. And maybe, I will not be very original, but I should just read that Artyom Igorevich deserves the academic right of physical mathematical sciences. Well, that's it. Thank you very much, Artyom Igorevich, Leonid Viktorovich, for your critical remarks. There are some typos. This has to do to number 20, to page 26. Yes, there's a typo because the director was written incorrectly on this line, but the correct form of the director was used when developing the algorithm itself. Thank you. Thank you very much. I am satisfied with it. Now I'd like to give the floor to Thomas Ricklick. Can you hear us, Thomas?
Yes, I can hear you.
Да, я могу, я вас слышу. Yes, you may.
Who was informed by the supervisor that my voice is quite important as a foreign member, so I present some greater parts of my report. So the main achievements of the thesis is construction of effective algorithms of generating records from distributions whose density have analytic forms, but the distributions functions do not have, in particular, gamma and normal distributions. Two basic tools were used here, and they are quite new here, especially the first one there. One is coincidence with the conditional distribution of the next record, given the previous record, with the left truncating parent distribution at the value of the preceding record. And the other is the method of rejection. And the method of rejection consists of generating another random variable with a known density, which has a multiplicative, which with a multiplicative constant majorizes the original density f. The value of y is accepted if an appropriate ratio f of y divided by c g of y is greater than u and independent standard uniform random variable. And the procedure gives the probability.
Извините, с тем, что не имеем Простите, вернемся через несколько минут, и вам об этом сообщим. Извините, мы вынуждены вас прервать. Простите, пожалуйста.
Should I speak slower?
Have to interrupt you because the Russian translation is not getting into the microphone.
Should I speak slower? So I don't understand what was the problem. So how can I solve the problem?
Just a technical break, if possible. Can you hear me, Thomas?
There is a troublesome silence. You interrupted me, but I don't know what I should do.
Thomas, there's a technical break because the listeners here cannot hear the Russian translation. Thomas,
Okay, technical break, okay.
Yeah, technical break, please. Thank you.
Уважаемые коллеги, технический перерыв закончен. Мы можем продолжать заседание, но я вынужден извиниться перед Томашем и просить его начать выступление сначала.
Your presentation from the beginning, Tomasz. Я решил сократить свой отзыв.
I only mentioned several critical remarks. So my first objection was that author did not properly describe the rejection method. He made much effort to determine, or perhaps I should wait for translation, or not. Should I continue? Do you listen me?
Слышим вас, слышим, хорошо слышим и видим.
Okay, should I continue? Or should I wait for translation into Russian? Should I continue?
Yes.
Okay. And my question was if I should wait after some sentences for translation into German, or I can continue my presentation. So, my objection is he made much effort for determining minimal constant.
Он сделал очень много усилий для того, чтобы определить.
These constants were the only one for which the method works. And well, I get an answer from the candidate that he agrees with my with objection. Did not and he sent me a good. I accepted this one. Well, my conclusion is positive, and I prepared it in formal way, which was accepted by say officers. So my conclusion is positive, and I listed a number of minor mistakes, which was most of them were typos, and I read the answer of Artem Pakhteev. He accepted that, well, there were mistakes, there were small mistakes, and there was also one question, I have one doubt about the record of the list of records presented in the paper, which looks suspicious, but it was explained for me, and also I remember it was during the presentation that the records for large samples are close to the numbers of records. That's why the numbers which looked suspicious were correct. Well, I finished my discussion of my report. I think if you need something more, I can extend my presentation, but now I stop.
Спасибо, Томаш. Скажите, пожалуйста, считаете ли вы достойным соискателя присвоения степени кандидата?
Do you consider the candidate worthy of being awarded the third degree?
Yes.
Да, я это уже упомянул в своем отзыве.
Yes.
Да, я снова могу.
Хорошо.
The results presented in the thesis constitute new, interesting, and valuable contribution to the analysis of ordered random variables. They are practically applicable as well. The thesis written by Artem Igorevich Pakhteev fulfills essential requirements established in the decree on the procedure of granting academic degrees in the St. Petersburg State University. And in my opinion, the applicant deserves granting the candidate degree in the mathematical and physical sciences, in specialty probability and mathematical statistics. Also, point 11 of the decree mentioned above has not been violated. This is my conclusion.
Спасибо большое, Томаш. Артем Игоревич, есть ли у вас что-нибудь в ответ на вопрос?
Thank you very much, Tomasz Michnik, for your very honest conclusions. I would like to answer some of your statements. First, about that the choice of C is not the only one. It is true that the concept C is not something unique, and the dominating density can be found by alternative ways, but the constant C should be chosen because such that it takes the smallest possible value. As far as the suspect of n records behavior, calculations are correct in the slide in the review. There's a proof. First we see the equivalence of f density, its density, through a derivative. It approximates 1, and therefore we can replace with the big F with density. The same thing with the theory of the records that the negative algorithm goes to 1 for any distribution with alpha greater than 1. We replace with an equivalent, and therefore we end up with the sequence of xn is to 1 and goes to 1, and the limit is equals 1. Therefore we can say that for all gamma distributions with alpha and 1, the ultimate result will be met, and the results of generation are correct. Thank you very much. Tomasz, are you happy with the answers to your critical? Да, я доволен. Да, все хорошо. Спасибо. Thank you very much for your participation. And now my own review. And I'll be very short. First of all, I identify this work as very relevant, that this work and that has to do with very relevant topic, and the results are very the main results are then cited in my review. The results are new and practically interesting and good to be applied. All the proofs are valid, and the experimental data support the results as well. The statistical methods can be applied to different industry and fields, industries and fields. As far as the in some formulations in the introduction, the ones formulating some results in subsection 1, so not all designations are defined, which makes it difficult to understand the text of the subsection without referring to the main part. See, for example, the notation Qn and Pn in the statements of theorems on page 11. There are some typos in the text on page 12. Instead of generated, one should write the Russian has the typo, and then instead of in page 121 in verse fraction, as far as the sampling of 1 million, but that doesn't find any proof why this value, why not 10 million or 100,000 or something. As far as the one more critical remark is there is the Borel-Cantelli lemma, the formulation of which is given later on page 61, but in the proof of assertion 4.02.1 on page 22, a reference is made. It seems more expedient to cite the formulation of the lemma before using it in the text. And then the critical remarks don't diminish the good impressions of the work. The work provides solutions to very many experimental problems, and these methods can be applied to different areas of the economy. The dissertation meets all the requirements. The content provides solutions. Proves the solutions to the main goal of the dissertation, and I just want to say that the dissertation includes publications that have been published in Web of Science and Scopus journals, and therefore the key issues, these key statements have been tested, and therefore I would like to conclude that the dissertation by Pakhteev, Artem Igorovich, deserves a candidate of sciences degree in physical and mathematical sciences. Item 11 in the regulations has not been violated. The chairman of the dissertation council, Professor of Statistics Modeling, Professor Krivolin. Nikolai Kimmich, I would like to answer your comments. Nikolai Kimovich, thank you very much for your professional attitude, but I would like to comment as far as formulating some results in subsection 1.2. I totally agree with you with the comment. I should have defined the notation used in this paragraph more clearly. However, Q and PN were previously defined on page 8. As far as the some typos, the text was written without in tech without word spell check, and therefore I have unfortunately let some typos creep in. As far as a million or not 1,000 or 7, but a million was selected because it was a large enough number of generations to determine the average value of the records, while not at all times consuming. With respect to the chi-square criterion, the 1,000 was chosen for reassurance, and in the beginning it seemed that it would not work. Larger sample size was probably appropriate for for chi-square. As far as the lemma Borel-Cantelli lemma, I totally agree with this remark. The Borel-Cantelli lemma should have been cited and defined earlier. Yes, it's true that I defined it a bit later. As far as the source codes of the programs presented in the appendix that are not documented, which complicates the readability. Yes, I agree. I should have accompanied the programs and the application with comments. Thank you very much. Dear members of the Dissertation Council, are you happy with the answers to your critical remarks? Thank you. No objections then. I know everybody is happy, and the floor is open now for discussion from the audience. No takers, and any questions via the internet link? No. Therefore, I would like to give the floor to the academic advisor. Can you hear me? I would like to thank everybody present, members of the Dissertation Council for their efforts, and я хотел бы
Алексей Васильевич, извините, я вынужден вас прервать. На самом деле, пожалуйста, говорите по-русски, потому что на самом деле перевод...
Because the interpreting is provided, so there's no... Thomas cannot hear what you're saying in English. I would like to say a special thank you to Thomas for his kindness and his readiness to be part of the council, Dissertation Council, the committee. As far as the dissertation itself, can I continue, please, in Russian though? Artem Igorovich was asked to continue my work and statistics. My works were more theoretical, and now there's an interest in more applied solutions. Therefore, I decided to ask him to work on generator records and extreme values, because before that applied research was not done to it and had not been done to it, and therefore this is a pioneer work. And of course, we thought that he would have been able to prove himself, and he has. The results have been published, as we noticed. 5 have been published in co-authorship with me, but I should say that half of the contribution certainly belongs to the candidate. He worked very hard. It's very hard for a researcher to go somewhere and speak, but he has participated in some conferences in St. Petersburg University, for example, research workshops, etc. And so it was fun to see how algorithms worked, and this is a great contribution to the field, and therefore he deserves the degree of candidate of physical and mathematical sciences. A great work, I think. Do we have any questions to the academic advisor? No questions. Okay. Then next item on the agenda, because we are doing this online. Any members of the station council or the candidate have any unanswered questions relating to the technical side of things in this committee? Yeah, everybody is satisfied. Okay, good. Then we continue to the voting procedure, but before that we have an opportunity to deliberate while our microphones are switched off. Do we need the secret deliberations, or can we just vote? No. Well, since all the reviews were positive, we can continue and vote, and we won't announce a break for the discussion, and therefore this is the most decisive moment. I would like everybody, all members of this station, to confirm that you all can hear us. Me, yes, I can hear you. Everything is fine. Good. I am also bound to say that according to the regulations, since Andrei Viktorovich was not available, that he is not formally allowed to vote, but his opinion will be taken into account. Now, I'd like to put to the vote the resolution of awarding the awarding of the candidate of sciences degree to Artyom Igorovich. Well, the verdict is legitimate if a positive decision, if not less than 2/3 of the station council votes for this positive resolution. So therefore, I would like to ask each one of the members of the station council how they vote. Melis Vyacheslav Borisovich, what's your opinion about conferring the third degree? I think he deserves the degree of physical and mathematical sciences. Nadezhda Viktorovna Grybkova, your opinion? I also think that Artyom Viktorovich Igorovich deserves the degree of candidate of physical and mathematical sciences. Frolov Andrei Nikolaevich, your opinion? I also think that Artyom Igorovich deserves the third degree. Razovsky Leonid Viktorovich, your opinion? I side with the previous opinions. I also think that he deserves. Tomasz, your opinion? Does he deserve?
Yes, my opinion is positive. Pakhteev deserves granting the degree.
Спасибо большое, Томаш. Я председатель.
Then, as chairman of the station council, I also vote, and my opinion is that Artyom Igorovich deserves the degree of physical mathematical sciences. Counting the votes, I can say that the following results. Are there 6 members of the Station Council? 1 vote is not counted. The results: 5 members voted for the resolution. No one voted against, and no abstentions. And therefore, the decision to award Artem Igorovich Pakhteev the third degree of candidate of physical sciences and the degree field 010105 theory of probability mathematics statistics is taken. The decision is taken. Dear colleagues, since our session included online communication with some members of the station, any members of the Station Council or the candidates, do they have any objections to the procedure? No. And then Artem Igorovich, you've heard the decision. Now your concluding remarks. I would like to thank everyone in the Station Council for this honor, and I hope in the future I will continue working in my field, and I would thank you very much for your positive attitude, for your honest and friendly reviews. I would like to thank especially my academic advisor. Well, without him I would have not achieved what I've achieved. His wise guidance helped me that. Thank you very much. Congratulations on this result. This session is now declared open. Thank you very much. All members of the Station Council participating and being patient with some technical